Okay, hello, I'm back. I'm going to make another little video clip for you on some material from chapter 8. And the thing I want to talk about real quick in this video is percent yield. Now, what is percent yield exactly? Well, anytime you have any kind of a process, you typically don't have 100% of the substance formed that could be formed. What do I mean by that? Well, we don't have perfect chemical processes in a real world, right? So maybe it just doesn't work perfectly, and so you start with a certain amount, which when we use stoichiometry, what do we find out? Well, if I start with this exact amount, I should get this other amount over here of product, right? But what happens in real life is we don't typically get that exact amount. We usually get a little bit less than that. So by taking the actual amount that we have yielded in a chemical reaction and dividing it by the amount we should have yielded and multiplying it by 100%, that's what we call our percent yield. Now, when we do stoichiometry, what we've done in chapter 7, would that be the actual yield that we're talking about, or would that be the theoretical yield? Well, when we talk about starting with a certain amount and ending up with a certain amount, right, from what we started with, that actually would be our theoretical yield. If the whole process works perfectly, we would have this amount as our product, right? So in all the stoichiometry you've done in chapter 7, we're talking about a theoretical yield. But like I said, we don't always get that theoretical yield. We usually get a little bit less, okay? So a problem that you've been given in the extra review problems I'm going to go over right now. And it is this particular reaction, okay? This chemical reaction says that if I start with 2 moles of silver nitrate and I add to that, or I react that with 1 mole of magnesium chloride, what I get is 2 moles of silver chloride and then 1 mole of magnesium nitrate. That's my chemical reaction. And what the problem tells me is that I start with 50 grams of magnesium chloride. So I've got 50 grams of this, okay? And I produce 125.1 grams of silver chloride. What is my percent yield? Now, this amount is my amount I started with, and I can use stoichiometry to come up with what? I can use that to come up with amount I should produce of of silver chloride, and that would be my theoretical yield. I can compare that to my actual yield. So this number here they're giving me, what is that? That is my actual yield. So 125.1 grams is my actual yield of silver chloride. That's what I actually got. What I need to do is figure out what my theoretical yield should be. If I start with this amount, how much should I produce of silver chloride? So how do I do that? We do that with stoichiometry. Okay, so here we go. So this is just like what we did in chapter 7. If I start with 50 grams of magnesium chloride, I can figure out how many moles of magnesium chloride that is, right? By using my molar mass, which I have up here. So for every 1 mole of magnesium chloride, I've got to start with 95.21 grams of magnesium chloride. And when I do that calculation, what I come up with is that that's actually 0.525 moles of magnesium chloride. Okay. Now, I can take the moles that I should produce, right, or that I started with, that I actually started with the magnesium chloride, and I can figure out how many moles that should produce of silver chloride. Let's go ahead and do that. So what's the relationship between them? Well, for every 1 mole of magnesium chloride, I'm going to produce 2 moles of silver chloride. So let's figure that out. 2 moles of AgCl, silver chloride, 1 mole of magnesium chloride. And so then I get 1.05 moles of silver chloride. That's the actual amount I should produce in moles. But I don't need it to figure out my actual yield here, my percent yield. I've got to have a theoretical yield that's in grams. Okay, so I'm going to take my 1.05 moles of silver chloride and I'm going to change it back into grams. Here's the molar mass for that, right? 1.05 moles of silver chloride for every 1 mole of silver chloride. I've got to have 143.32 grams of silver chloride. I'm sorry, and that ends up being 150 grams of silver chloride. However, I have 3 sig figs over here. I want to report 3, so I'm going to go ahead and write that as 1.50 times 10 squared grams. Okay? That is my theoretical yield. If I start with this, that means that equals, if I start with 50 grams, that equals 0.525 moles of magnesium chloride, which relates to 1.05 moles of silver chloride, which relates to 1.50 times 10 squared grams. Okay? Then what I can do is I can go back to my actual yield, divide it by my theoretical yield, multiply it by 100%, and that will give me my percent yield. So I'm going to do that real quick. That's my last step. Okay? So if I've got 125.1 grams of silver chloride, that's my actual yield. That's what I actually got, divided by 1.50 times 10 squared grams of silver chloride times 100%. And when I do that, I get 83.4%. What does that mean? That means that the processes I used allowed me to have 83.4% of what I could have produced if all of my processes were perfect and I was able to react, and from my actual initial reactant, if I was able to produce everything perfectly, I would have ended up with 150 grams. I got 125. That is 83% of what I could have yielded. So that is how percent yield works.